Hey there, curious minds. Let me hit you with a brain bender right out of the gate. Antarctica is officially classified as a desert, the driest one on Earth, actually. And yet, this frozen wasteland is sitting on 70% of all the fresh water on our planet. Yeah, the driest place holds most of the water. Geography just loves messing with us like that. Here's the thing that should keep you up at night. We've got rovers doing donuts on Mars. We've mapped the dark side of the moon. We've sent probes to the edge of our solar system. And yet there's a continent right here on Earth that we barely understand. A place bigger than Europe, covered in mysteries 3 miles deep, and we're basically standing at its doorstep going, well, this is awkward. While the Arctic lets us build research stations and sail cruise ships through it, Antarctica looks at our best technology and laughs in sub-zero temperatures. So today we're going to find out why this frozen giant refuses to be conquered. But first, smash that like button if you're into these kinds of rabbit holes, and drop a comment telling me where you're watching from. I want to know which corner of this warming planet is tuning in while we talk about the coldest one. Ready to feel very small and very impressed? Let's dive in. Now, here's where things get genuinely fascinating, and I promise this is not going to be a geography lecture that makes you want to take a nap. Although, if you are watching this to fall asleep, hey, no judgment here. But stick with me, because understanding this one fundamental difference is going to unlock everything else we talk about today. It is the key to the whole mystery. And the mystery is this: why can we sail cruise ships through the Arctic while Antarctica basically tells humanity to go home and rethink its life choices? The answer comes down to what each pole actually is. And spoiler alert, they are basically opposites wearing the same icy costume. Think of them as twins who look similar from a distance, but have completely different personalities, life goals, and definitely different attitudes toward visitors. Let us start with the Arctic, because the Arctic is the friendly one. Relatively speaking, of course. The Arctic is not a continent at all. It is an ocean. A frozen ocean, sure, but an ocean nonetheless. Picture a giant bowl of water that got really, really cold and developed a crust on top. That crust is the Arctic ice cap, sea ice floating on the Arctic Ocean. And here's the crucial part. This frozen ocean is surrounded by land. You've got North America curving around from one side, Europe and Asia wrapping around from the other. It is like the continents are giving the Arctic a big, warm group hug. And that hug matters more than you might think. See, all that land surrounding the Arctic acts like a natural windbreak. It blocks the worst of the ocean currents from pulling heat away. It allows relatively warmer air masses from the south to occasionally drift northward. The result? The Arctic, while definitely not a tropical vacation destination, is almost cozy compared to its southern counterpart. Average winter temperatures hover around -30 to -40 degrees Celsius. Cold enough to freeze your regrets solid, sure, but survivable, manageable. The kind of cold where humans looked at it thousands of years ago and said, yeah, we can work with this. And work with it they did. Indigenous peoples have lived in the Arctic for at least 20,000 years. The Inuit, the Yupik, the Sami, the Nenets, entire cultures developed sophisticated ways to thrive in this environment. They built homes, developed hunting techniques, created trade networks, raised families. Generation after generation, living their lives in a place that would kill an unprepared person in hours. That is not just survival, that is civilization. The Arctic was harsh, but it was never off limits to humanity. Now flip the globe over. Literally, turn it upside down. Because Antarctica is not just geographically opposite, it is conceptually opposite in almost every way that matters. Antarctica is not an ocean surrounded by land. It is land surrounded by ocean. A massive continental landmass, bigger than Europe, bigger than Australia, sitting at the bottom of the world like a giant frozen island that nobody can reach. And instead of being hugged by protective continents, Antarctica is completely isolated. There is nothing between it and the rest of the world except hundreds of miles of the angriest, most violent ocean water on the planet. No windbreaks. No warm air masses drifting in from friendly neighbors. Just endless exposure to the full fury of global weather systems. This inverted architecture changes absolutely everything. And I mean everything. It is the reason Antarctica has no indigenous population. It is the reason the continent was not even seen by human eyes until 1820. It is the reason we have better maps of Mars than we do of what lies beneath Antarctic ice. One simple geographic flip and you get two completely different worlds. Let me paint you a picture of just how different these worlds are. In the Arctic, polar bears wander across the ice, hunting seals, doing polar bear things. Polar bears are the iconic Arctic predator, the white, fluffy murder machines that grace nature documentaries and soda commercials alike. Now here is a question. Why are there no polar bears in Antarctica? After all, Antarctica has plenty of ice, plenty of seals, plenty of everything a polar bear could want. Seems like paradise, right? The answer is wonderfully simple. Polar bears cannot get there. There is no land bridge. There is no ice road connecting the Arctic to the Antarctic. There are roughly 12,000 miles of ocean, multiple continents, and the entire tropical zone in between. Polar bears evolved in the Arctic because the Arctic is connected to places where bears could evolve. Antarctica, meanwhile, has been isolated for so long that its ecosystem developed entirely separately. Penguins rule the Antarctic because there were no land predators to eat them. If you dropped a polar bear in Antarctica, it would probably think it died and went to heaven. Unlimited penguins who have never learned to fear land-based hunters. But evolution does not work on hypotheticals, and geography is destiny. This isolation is not just about wildlife, though. It is about climate itself. Remember how I said the Arctic gets that warm continental hug? Antarctica gets the opposite. It gets the cold shoulder, literally. The Southern Ocean that surrounds Antarctica is not just a moat, it is a climate wall. We will talk more about this later, but there is a massive current that circles the entire continent, cutting it off from the warmer waters to the north. This current has been flowing for roughly 34 million years, and in that time, it has turned Antarctica into a freezer that makes the Arctic look like a pleasant autumn afternoon. How cold are we talking? The coldest temperature ever recorded on Earth, anywhere, at any point in human measurement, was at the Soviet Vostok station in Antarctica. Minus 89.2 degrees Celsius. That is minus 128.6 Fahrenheit for those of you keeping score at home. At that temperature, steel becomes brittle. Rubber shatters like glass. The moisture in your breath freezes before it leaves your mouth and falls to the ground as tiny ice crystals. Your exposed skin would get frostbite in under a minute. And that was just at a research station, not even at the coldest possible point on the continent. Satellite measurements have detected surface temperatures approaching minus 98 degrees Celsius in certain elevated regions. That is cold enough to make the Arctic feel like a beach vacation. Now you might be thinking, okay, so Antarctica is colder. Big deal. Humans have figured out how to deal with cold. We invented coats, heaters, insulated buildings. Why should a few extra degrees matter? And that is a fair question, but the answer reveals just how different this place really is. In the Arctic, cold is a challenge to overcome. In Antarctica, cold is a fundamental feature of reality that dictates what is and is not possible. The Arctic has seasons where temperatures moderate, ice melts, and life blooms. There is a summer, even if it is short. The permafrost might stay frozen, but the top layer of soil thaws enough for plants to grow. Mosses, lichens, grasses, even small shrubs manage to exist. Where there are plants, there are insects. Where there are insects, there are birds. Where there are birds, there is a whole ecosystem humming along. Antarctica has none of that, not in any meaningful sense. The interior of the continent is so cold, so dry, and so wind-blasted that almost nothing can survive. We are talking about a place that makes the Sahara Desert look like a thriving oasis. The average precipitation in interior Antarctica is less than 2 inches per year, less than most deserts receive. Except instead of sand, you get ice. The snow that falls does not melt, it accumulates. Year after year, century after century, millennium after millennium, it piles up and compresses into ice. The ice sheet covering Antarctica is up to 3 miles thick in places. 3 miles. That is taller than most mountains, and it is made entirely of frozen water that has been building up for millions of years. This creates a paradox that would make any physicist smile. Antarctica is classified as a desert because of how little precipitation it receives, yet it contains 70% of all the fresh water on Earth. The driest continent is also the wettest, in a sense. It just takes a very, very long time for that water to go anywhere. We are talking about ice that fell as snow during the Roman Empire and still has not made it to the ocean. We are talking about ice at the bottom of the sheet that fell when mammoths still roamed Europe. The continent is a time capsule, a frozen archive of Earth's atmospheric history, and it is utterly hostile to anything that wants to live on its surface. This brings us to the human element, because that is really what this story is about. Why can we explore the Arctic, but not Antarctica? The Arctic had permanent indigenous populations. It had trading posts, settlements, seasonal camps. By the medieval period, Vikings were sailing around Greenland, establishing colonies, arguing about land rights like it was just another piece of real estate. Cold, sure. Dangerous, absolutely. But fundamentally livable for people with the right knowledge and equipment. Antarctica remained completely unknown until the 19th century. Humans had been on Earth for hundreds of thousands of years, had spread to every continent, had crossed oceans and deserts and mountain ranges, and nobody had ever set foot on Antarctica. Not because they were not curious, not because they lacked courage, but because getting there was essentially impossible with pre-industrial technology, and surviving there was impossible with any technology until very recently. When explorers finally did reach Antarctica in the early 1800s, they found exactly what you would expect from everything we have discussed: a frozen wasteland surrounded by treacherous seas, battered by constant winds, and offering absolutely nothing in terms of resources, shelter, or hospitality. The continent actively rejects human presence. It is not indifferent to us the way a desert or a jungle might be indifferent. It is hostile. It fights back. Every expedition to Antarctica's interior has been a battle against an environment that seems almost personally offended by human ambition. The first people to reach the South Pole did so in 1911, and one of those expeditions ended in tragedy. We will talk about that later. It is one of the most dramatic stories in exploration history. But for now, just consider the timeline. Humans reached the North Pole in 1909, and it was considered a major achievement. But the North Pole is just a spot on floating ice in the middle of an ocean. You can sail relatively close and then trek across the ice to reach it. The South Pole is in the middle of a continent, buried under ice, surrounded by mountains, hundreds of miles from the nearest coast, in the coldest and windiest place on the planet. Reaching it was not just an achievement. It was a miracle of human determination, and probably a fair amount of luck. And here's the thing that should really blow your mind. Even today, with all our technology, all our satellites, all our heated research stations and specialized equipment, we still cannot truly explore Antarctica the way we explore other places. We have permanent research bases, yes. We have scientists spending months at a time studying the ice and the atmosphere and the wildlife on the coasts. But the interior of the continent remains almost as mysterious as it was a century ago. We know more about the surface of the moon than we know about what lies beneath the Antarctic ice sheet. This is the fundamental reality that shapes everything about this continent. The Arctic is a frozen ocean that humans have navigated, settled, and exploited for millennia. Antarctica is a frozen fortress that keeps us at arm's length even in the 21st century. Same ice, same cold, completely different stories. And understanding this difference is the first step toward understanding why Antarctica remains Earth's last great mystery, a place that seems designed to test the limits of what humanity can achieve, and to remind us that there are still frontiers we have not conquered. So we have established that Antarctica is a continent surrounded by ocean, while the Arctic is an ocean surrounded by continents. That alone explains a lot. But if you think geography is the only thing keeping us out, oh boy, are you in for a treat. Because Antarctica has backup security systems, multiple layers of them. And these defenses make medieval castle walls look like a polite suggestion. Imagine you are an explorer in the 19th century, and you have somehow convinced yourself that sailing to the bottom of the world is a good career move. You have a ship, a crew, and presumably a death wish. You set sail from South America, or South Africa, or Australia, heading south toward the great unknown. At first, things are fine. Cold, but manageable. The seas are rough, but you have seen rough seas before. And then you hit the 50s. The roaring 40s. The furious 50s. The screaming 60s. These are not heavy metal band names, though they absolutely should be. These are the latitudes of the Southern Ocean, and they earned those nicknames through centuries of maritime suffering. See, in the Northern Hemisphere, when winds circle the globe at these latitudes, they bump into continents. North America gets in the way. Europe gets in the way. Asia definitely gets in the way. The land masses break up the wind patterns, slow them down, redirect them. In the Southern Hemisphere, nothing. There is no land between roughly 40 degrees south and the Antarctic coast. The wind just goes. It circles the entire planet without hitting a single speed bump. It builds and builds and builds, gathering energy from thousands of miles of open ocean, until you have winds that would make a Category 5 hurricane feel insecure about itself. Ships crossing these latitudes in the age of sail called it running the easting down, which sounds almost poetic until you realize it meant weeks of being tossed around like a cork in a washing machine while praying your mast did not snap in half. But here is the thing. Those are just the winds getting to Antarctica. The winds on Antarctica are somehow worse. Meet the katabatic winds, which is a fancy Greek word that basically means going downhill. And let me tell you, these winds do not mess around. Picture the Antarctic ice sheet, a dome of ice up to 3 miles high in the center, sloping down toward the coasts on all sides. Now, cold air is denser than warm air. It is heavier. And when heavy air sits on top of a giant sloped surface, gravity has opinions about where that air should go. The answer is down. Always down. Toward the coast. This creates a drainage system, except instead of water flowing downhill, you have air. Massive rivers of freezing air cascading off the polar plateau, accelerating as they go, funneling through valleys and ice canyons, picking up speed like a freight train with no brakes. By the time these winds reach the coast, they can exceed 200 miles per hour. That is stronger than most tornadoes. That is, your tent is now in a different time zone territory. That is, I hope you are not emotionally attached to anything you brought with you levels of wind. And unlike hurricanes or tornadoes, which are dramatic but temporary, katabatic winds are a permanent feature of Antarctica. They blow constantly, every single day. The continent is essentially exhaling frozen death at all times, pushing anything that tries to approach back out to sea. Early explorers described the experience as being sand-blasted, except instead of sand, it was ice crystals moving at bullet speeds. Your face would be raw and bleeding within minutes of exposure. Your equipment would be scoured clean of any markings. Your footprints would vanish almost as soon as you made them. Commonwealth Bay in East Antarctica holds the record for being the windiest place on Earth at sea level. The average wind speed there is around 50 miles per hour. Average. That means 50 miles per hour is a calm day. On a bad day, you are looking at winds that would ground every airplane on the planet. The first expedition to winter there, led by Douglas Mawson in 1912, spent an entire year essentially trapped in their hut, unable to venture outside for more than brief periods. They had to crawl on hands and knees to avoid being blown away. They lost equipment, they lost supplies, and several men lost their lives. And this was just the wind. Not the cold, not the isolation, just the wind. Now, if the winds were not enough of a deterrent, Antarctica has a second line of defense that is even more impressive. The Antarctic Circumpolar Current. This is the largest ocean current on the planet, and calling it a current feels like calling the Amazon River a stream. We are talking about a massive conveyor belt of water that flows continuously around the entire continent, west to east, connecting the Atlantic, Pacific, and Indian Oceans into one giant loop. The numbers here are staggering. The Antarctic Circumpolar Current moves approximately 130 million cubic meters of water per second. For comparison, that is about 600 times the flow of the Amazon River, every second. It is the aquatic equivalent of a highway, where all the lanes are going the same direction at maximum speed, forever, and there are no exits. Ships trying to approach Antarctica have to cross this current, which means fighting through some of the most turbulent waters on Earth while being pushed sideways by a force that could move mountains if mountains were in the way. But the current does something even more important than just making navigation difficult. It acts as a thermal barrier. Remember how we talked about the Arctic getting warmth from surrounding continents? The Antarctic Circumpolar Current is the reason Antarctica gets no such charity. Warm water from the tropics drifts south, carrying heat that could theoretically moderate Antarctic temperatures. But when that warm water hits the circumpolar current, it gets deflected, pushed away, told to find somewhere else to be. The current has been doing this for about 34 million years, ever since the Drake Passage opened up and allowed water to flow freely around the continent. In geological terms, that is when Antarctica's fate was sealed. That is when the freezer door closed. Before the current existed, Antarctica was actually quite pleasant. Fossil evidence shows that the continent was once covered in forests. There were dinosaurs wandering around. The climate was temperate, even warm in some regions. But once that circumpolar flow established itself, the continent began cooling rapidly. The ice sheets started forming. The forests died. And Antarctica transformed from a livable landmass into the frozen fortress we know today. This is worth pausing on because it reveals something profound about how our planet works. A single ocean current, established by the slow dance of continental drift, fundamentally changed the climate of an entire continent and, by extension, the entire world. The Antarctic ice sheet reflects sunlight back into space, cooling global temperatures. It drives deep ocean circulation patterns that affect weather systems thousands of miles away. It stores enough frozen water to raise global sea levels by nearly 200 feet if it melted. All of this because 34 million years ago, two chunks of land drifted far enough apart to let water flow through the gap. So when we ask why Antarctica is so hard to explore, the answer is not just, it is cold, or it is far away. The answer is that the continent has built-in defense systems that have been operating for longer than humans have existed, longer than most. Mammal species have existed, longer than the Himalayas have been tall. The winds scour the surface clean. The current locks the cold in place. Together, they create a barrier that does not just make exploration difficult, it makes permanent human presence essentially impossible without constant technological intervention and supply lines from the outside world. Every research station in Antarctica is a tiny bubble of survivability in an ocean of hostility. Cut off the supply ships, and those stations become tombs within months. The continent tolerates our presence the way a lion tolerates a fly, barely noticing, but fully capable of ending the arrangement whenever the mood strikes. And that is assuming the mood is good. When Antarctica decides to remind us who is in charge, people die. All right, so we have covered why Antarctica wants to kill you. But here's the twist in our story. This frozen nightmare is also one of the most valuable places on Earth for understanding our planet's past and, more importantly, its future. And the key to that value is not on the surface, it is buried deep beneath it. Remember how I mentioned that snow in Antarctica does not melt? It just accumulates, year after year, compressing under its own weight until it becomes ice. Well, that process has been happening for millions of years, and every single layer of that ice is essentially a time capsule. A snapshot of what Earth's atmosphere was like when that snow originally fell. Think about it like this. When snow forms in clouds, it traps tiny bubbles of air from the surrounding atmosphere. Those bubbles contain whatever gases were floating around at that moment. Oxygen, nitrogen, carbon dioxide, methane, whatever else was in the mix. When the snow falls and gets buried by more snow, those bubbles get sealed inside. They are literally samples of ancient air, preserved in frozen storage, waiting for someone curious enough to dig them out. Scientists figured this out decades ago, and since then, extracting ice cores from Antarctica has become one of the most important fields in climate research. The process is exactly what it sounds like. You drill a long, hollow tube deep into the ice sheet, and you pull out a cylinder of ice, a core, that contains layers going back through time. The deeper you drill, the older the ice gets. And the Antarctic ice sheet is deep enough to take us back hundreds of thousands of years. The current record holder is an ice core extracted from a site called Dome C in East Antarctica. That core reaches down about 3 kilometers, nearly 2 miles, and contains ice that is over 800,000 years old. 800,000 years. For perspective, modern humans have only existed for about 300,000 years. This ice was forming when our ancestors were still figuring out fire. It has been sitting there, quietly preserving samples of the atmosphere, while entire species evolved and went extinct above it. And what does this frozen archive tell us? Well, this is where things get both fascinating and slightly terrifying. By analyzing the gas bubbles in ice cores, scientists can track exactly how much carbon dioxide was in Earth's atmosphere at any given point in the past 800 millennia. They can correlate those CO2 levels with temperature records extracted from the ice itself, using isotope ratios that act like ancient thermometers. And the pattern they found is unmistakable. Throughout those 800,000 years, carbon dioxide levels fluctuated naturally between about 180 and 280 parts per million. When CO2 was high, temperatures were warm, interglacial periods like the one we are living in now. When CO2 was low, temperatures dropped, and ice ages gripped the planet. The two variables moved in lockstep, dancing together through cycle after cycle of warming and cooling. It is one of the most elegant demonstrations of climate science you could ask for, written in ice by the planet itself. Now here's the punchline, and it is not a funny one. Current atmospheric CO2 levels are over 420 parts per million, That is higher than anything in the 800,000-year ice core record. Not just a little higher, dramatically higher. We have left the dance floor entirely and started doing something the planet has never seen, at least not within the time frame that ice cores can measure. The frozen diary of Earth's atmosphere basically ends with a cliff, and we're the ones who built it. But reading this diary is not easy. Ice cores are incredibly fragile scientific specimens. You cannot just yank them out of the ground and toss them on a truck. The drilling process alone takes years and costs hundreds of millions of dollars. The equipment has to operate in conditions that would shut down most machinery. Extreme cold, howling winds, complete isolation from supply chains. Drill bits break, engines freeze, power systems fail. And if anything goes wrong at depth, you might lose years of work in a single accident. Once you actually have a core, the challenges continue. The ice has to be kept frozen during transport, which sounds simple until you remember that you are in the most remote place on Earth with no roads and limited air support. Samples get shipped to laboratories in specially refrigerated containers where they are stored at precisely controlled temperatures and analyzed using equipment that costs more than most houses. A single ice core can generate decades of research as scientists examine different layers, run different tests, and squeeze every possible drop of information out of these irreplaceable samples. And there is another problem: contamination. The whole point of ice cores is that they contain pristine samples of ancient atmosphere. If modern air gets mixed in, if someone breathes near an exposed sample, if equipment introduces foreign gases, if handling procedures are not absolutely perfect, the data becomes worthless. Scientists working with ice cores operate with the kind of obsessive cleanliness protocols you usually see in semiconductor manufacturing or surgical theaters. One mistake can ruin samples that took millions of years to form and will never be recovered. Despite these challenges, ice cores have revolutionized our understanding of climate change. They showed us that the planet's climate is far more dynamic than anyone previously imagined, capable of swinging between warm and cold states faster than geological processes would suggest. They gave us the baseline data that makes current warming trends so alarming. We know what normal looks like over 800,000 years, and what we are doing now is not normal. They even revealed unexpected events, like the Younger Dryas, a period about 12,000 years ago, when temperatures suddenly plummeted for 1,000 years, before snapping back to warm conditions almost overnight in geological terms. The ice remembers everything. Volcanic eruptions show up as layers of sulfur and ash. Forest fires leave chemical signatures. Changes in solar activity are recorded in isotope ratios. The rise and fall of lead pollution from ancient Roman mining operations is visible in ice cores from Greenland, showing peaks during the Roman Empire and drops during the plague years. In Antarctica, the ice is clean enough to detect pollutants from the other side of the world, including the nuclear tests of the 20th century, which left radioactive markers that scientists use to date recent layers precisely. This is what makes Antarctica so valuable, despite its hostility. The continent is essentially a 3-mile thick hard drive containing the operating system records of planet Earth. We cannot live there, we can barely survive there, but we desperately need to read what it has stored. And we are only just beginning to access that information. The 800,000-year core is impressive, but scientists believe older ice exists, potentially millions of years old, buried in locations we have not yet reached. Finding and extracting that ice could push our climate record back to periods when CO2 levels were similar to what we are creating today, giving us a glimpse of what might be waiting for us in the coming centuries. The frozen continent that refuses to be explored is also the one place that might hold the answers to our most pressing questions about the future. The irony is not lost on anyone working in Antarctic research. We need to understand this place, and this place seems designed to prevent exactly that. So far, we have talked about Antarctica as if it were just a giant ice cube sitting at the bottom of the world. And honestly, that is how most people picture it. A flat, white expanse of frozen nothing, maybe with some penguins waddling around for visual interest. But here is where the story takes a turn into the genuinely mind-bending. Because underneath that white shroud lies a secret that took us until the 20th century to even suspect, and we are still working out the details today. Antarctica is not a flat ice cube. It is a fully realized continent with mountains, valleys, canyons, and geological features as complex and dramatic as anything you would find in Europe or North America. We just cannot see any of it because it is buried under up to 3 miles of ice. It is like someone took the Alps, dropped a massive white blanket over them, and then dared you to figure out what was underneath without lifting the blanket. Good luck with that. The technology that finally let us peek beneath the ice is called ice-penetrating radar, and it works pretty much how it sounds. You fly an airplane or drag equipment across the surface, send radio waves down through the ice, and measure how they bounce back. Different materials reflect radar differently, so you can build up a picture of what is down there, sort of like an ultrasound for glaciers, except the patient is a continent, and the diagnosis is always way more complicated than we expected. When scientists first started systematically mapping subglacial Antarctica in the late 20th century, what they found was astonishing. The trans-Antarctic mountains, which are partially visible because they poke above the ice in some places, turned out to extend much farther and deeper than anyone realized. These mountains stretch for over 2,000 miles across the continent, essentially splitting Antarctica into two distinct regions, East Antarctica and West Antarctica. And mountains is not an exaggeration. Some peaks rival the European Alps in height, with summits reaching over 14,000 feet. You just cannot see them because they are wearing ice hats the size of small countries. But the real showstopper, the discovery that made geologists spit out their coffee, was the Gamburtsev Mountains. These are not partially visible mountains that extend under the ice. These are completely buried mountains, 100% submerged. Not a single peak breaks the surface. They are ghost mountains, and they should not exist. Here is why the Gamburtsev Range is such a head-scratcher. Mountains form through geological processes, tectonic plates colliding, volcanic activity, that sort of thing. And those processes leave marks. Mountains are supposed to be young and sharp if they are still being built, or old and worn down if the forces that created them have stopped. The Himalayas are young and dramatic because India is still crashing into Asia as we speak. The Appalachians in eastern North America are old and rounded because they stopped growing hundreds of millions of years ago, and erosion has been smoothing them out ever since. The Gamburtsev Mountains are old, really old, over 1 billion years by some estimates. But they are not worn down. They have sharp peaks and deep valleys, like they were carved yesterday. This makes absolutely no sense according to standard geological models. 1 billion years of erosion should have ground these mountains into gentle hills at best. Instead, they look fresh, preserved in pristine condition like geological specimens in a museum. The best explanation scientists have come up with is that the ice itself protected them. When Antarctica froze over, the ice sheet acted like a giant preservation dome, stopping erosion in its tracks. The mountains have been sitting there in cold storage, essentially unchanged, while the rest of the world's geology kept churning away. They are time capsules from an era when the continents were in completely different positions, and life on Earth was still figuring out basic multicellular cooperation. And the Gamburtsevs are just one feature of this hidden landscape. Radar surveys have revealed deep valleys that would rival the Grand Canyon if we could see them. There are vast basins where the bedrock actually sits below sea level. If the ice melted, these areas would flood and become ocean. West Antarctica in particular is surprisingly aquatic beneath its frozen surface, with bedrock that dips and rises like a submerged archipelago. Some researchers have suggested that if all the ice disappeared, West Antarctica would look less like a continent and more like a scattered collection of islands, fundamentally changing our maps in ways that would require a lot of textbook revisions. There are also volcanic features hidden under the ice. Mount Erebus, which is visible and active on Ross Island, is not alone. Scientists have identified dozens of volcanoes beneath the ice sheet, some of which may still be active. The idea of volcanoes erupting under miles of ice is not exactly comforting, and researchers are still working out what effects this geothermal activity might have on ice sheet stability. Nothing says complex system we do not fully understand quite like discovering that the frozen continent is also partially volcanic. The frustrating part of all this is that we can map these features, but we cannot actually visit them. The mountains, valleys, and canyons beneath Antarctic ice are as inaccessible as the surface of Jupiter's moons. More inaccessible, arguably. At least with Jupiter's moons, you just need a really good rocket and a lot of patience. With subglacial Antarctica, the features are right there, just a few miles below your feet. But those few miles might as well be the distance to another planet. You cannot drill through 3 miles of ice to go sightseeing. You cannot send submarines through solid frozen water. The hidden continent will remain hidden for the foreseeable future, visible only through the ghostly echoes of radar returns and the educated guesses of scientists who will never see their subjects with their own eyes. This is what makes Antarctica so uniquely frustrating for explorers and scientists alike. It is not just that the surface is hostile, though it absolutely is. It is that there is an entire world beneath that surface. A world we can detect but cannot reach, study but not visit, map but not explore. The continent keeps its secrets locked away under a frozen vault, and we are left pressing our faces against the glass like kids at an aquarium, knowing there is something amazing in there, but unable to get any closer. Now, if buried mountains were not enough to make Antarctica feel like a science fiction setting, let me introduce you to something even stranger: the subglacial lakes. Yes, lakes, liquid water, sitting beneath miles of ice, in complete darkness, cut off from the atmosphere and sunlight for longer than most species have existed on Earth. When this idea was first proposed, plenty of scientists were skeptical. How could liquid water exist in the coldest place on the planet? The logic seemed straightforward. Water freezes below 0 degrees Celsius. Antarctica is way below zero, therefore no liquid water. Case closed. Except the case was not closed, because Antarctica, as we have established, does not play by normal rules. The answer lies in pressure and geothermal heat. When you stack 3 miles of ice on top of something, the pressure at the bottom is immense, enough to lower the freezing point of water significantly. Add in the fact that Earth's interior is hot, constantly radiating heat upward through the crust, and you get a situation where the base of the ice sheet can be warm enough to maintain liquid water, despite the frozen nightmare above. The ice acts as an insulating blanket, trapping geothermal heat and creating conditions where water can exist in liquid form indefinitely. Scientists first confirmed the existence of subglacial lakes in Antarctica in the 1990s, and since then, the count has grown to over 400. 400 lakes, hidden beneath the ice, ranging from small ponds to bodies of water that rival the Great Lakes in size. Some of them are connected by subglacial rivers, creating an entire hidden hydrological system that flows and circulates without ever seeing the sun. It is like discovering that your basement has a swimming pool you never knew about. Except the basement is a continent, and the swimming pool has been there for millions of years. The largest and most famous of these hidden lakes is Lake Vostok, located beneath the Russian Vostok Research Station in East Antarctica. Lake Vostok is roughly the size of Lake Ontario, about 12,000 square miles of liquid water sitting beneath 2.5 miles of solid ice. It is one of the largest lakes on Earth, and until a few decades ago, nobody knew it existed. The lake has been sealed off from the outside world for somewhere between 15 and 34 million years, depending on which estimates you believe. To put that in perspective, when Lake Vostok was last exposed to open air, there were no humans. There were no great apes. Mammals were still relatively new to the whole being the dominant land animals thing. The lake has been sitting there in darkness, isolated and unchanged, while the entire story of human evolution played out above it. Naturally, this raises a fascinating question. Is anything alive down there? The possibility of life in Lake Vostok and other subglacial lakes has captivated scientists since these features were discovered. The conditions are extreme: no sunlight, limited nutrients, crushing pressure, isolation for millions of years. But life on Earth has proven remarkably creative at finding ways to survive in ridiculous circumstances. We have found organisms living in boiling hot springs, in acid pools, in the depths of the ocean where no light penetrates. Extremophiles, they are called, and they have taught us that life's boundaries are much wider than we once assumed. If life exists in Lake Vostok, it would have evolved in complete isolation for longer than most species survive on the surface. Whatever is down there, bacteria, archaea, something we have never encountered, would be entirely unique, a separate branch of life's family tree that diverged tens of millions of years ago. It would be like finding a time capsule from the age of dinosaurs, except the capsule is still running, and the contents might be alive. The scientific value of such a discovery would be incalculable. It would redefine our understanding of where and how life can exist. But here is where the story gets complicated, because we face a dilemma that sounds like the setup for a cautionary science fiction movie. How do you explore a pristine environment without destroying the thing you are trying to study? The problem is contamination. Earth's surface is teeming with microorganisms. They are on our skin, in our breath, on every piece of equipment we touch. If we drill through 2 miles of ice to reach Lake Vostok and accidentally introduce surface bacteria into the lake, we could fundamentally alter an ecosystem that has been isolated for millions of years. Worse, we might never know what was originally there versus what we brought with us. The act of exploration could erase the very thing we were hoping to discover. The Russian team that drilled down to Lake Vostok spent years developing protocols to minimize contamination, and they were still not entirely successful. When they finally reached the lake water in 2012, the drill used kerosene and freon as lubricants, chemicals that are definitely not part of the natural Lake Vostok environment. The first samples brought up were almost certainly contaminated with surface organisms and drilling fluids. Scientists are still arguing about what, if anything, the results actually tell us about life in the lake. Other research teams have tried different approaches. British scientists targeted Lake Ellsworth with a hot water drilling system designed to be cleaner than mechanical drills. But the expedition failed due to technical problems before reaching the lake. American researchers successfully sampled Lake Whillans using carefully sterilized equipment and found microbial life. But Lake Whillans is much younger and shallower than Vostok, connected to the broader subglacial system rather than isolated for millions of years. It was still a major achievement, proving that life exists beneath Antarctic ice. But it did not answer the bigger question about truly ancient, truly isolated ecosystems. The situation is a perfect encapsulation of Antarctica's central paradox. Here is something we desperately want to understand. A window into how life might survive in isolated extreme environments, with direct implications for whether life could exist on icy moons like Europa or Enceladus. And yet the act of reaching that window might shatter it. We're like archaeologists who suspect there is a priceless artifact inside a sealed tomb, knowing that opening the door might crumble the artifact to dust. Some scientists argue that we should develop completely new technologies before attempting further subglacial exploration. Robotic probes that can be sterilized to extraordinary standards, sampling techniques that minimize contact, ways to study the lakes without physically entering them. Others argue that the scientific value is too great to wait, that we need to accept some level of contamination risk and proceed carefully. The debate continues, and in the meantime, the lakes sit there in darkness, keeping whatever secrets they hold locked away beneath the ice. What we do know is that these lakes are not static. They drain and fill, connected by subglacial channels that can suddenly release massive amounts of water. In 2006, scientists detected a flood beneath the Antarctic ice sheet. A subglacial lake had emptied, sending water rushing toward the coast at rates that would have been alarming if they had happened on the surface. The ice sheet above actually dropped measurably as the water drained away. This was not ancient history. This was happening in real time, detected by satellites and seismic instruments. The hidden water system beneath Antarctica is dynamic, active, and doing things we are only beginning to understand. So add this to the list of reasons why Antarctica remains unexplored in any meaningful sense. It is not just the cold, the wind, the isolation, or the impossible distances. It is that even when we find something we desperately want to study, the very act of studying it threatens to destroy what makes it valuable. The continent is not just hostile, it is fragile in ways that demand a level of caution we rarely apply anywhere else on Earth. We can touch it, but we are not sure we should. We can reach it, but we might regret the reaching. The lakes of eternal darkness wait beneath the ice. Patient as only something millions of years old can be patient. They have outlasted civilizations, ice ages, mass extinctions. They will probably outlast our current debates about how to study them. And when we finally do find a way to look inside without breaking what we find, they might have the most surprising story of all to tell. We have spent a lot of time talking about how Antarctica is essentially a giant no to human ambition. The winds say no. The cold says no. The ice says no with particular enthusiasm. But here is where the story gets philosophical, because Antarctica is not just hostile to humans, it is hostile to life itself. Or at least, that is what we thought for a very long time. And as with most things involving this continent, we were wrong in ways that are both humbling and genuinely exciting. Let us start with what we can see, which is not much. The surface of Antarctica is, biologically speaking, about as dead as a place can get while still being on Earth. No trees, no shrubs, no grass, no flowers. Nothing green for thousands of miles in any direction. The interior of the continent is essentially sterile, a frozen desert where the only things moving are ice crystals driven by the wind. If you walked 100 miles inland from the coast, you would not encounter a single living thing larger than a microbe. Probably not even that. This is not an exaggeration for dramatic effect. The Antarctic interior genuinely has less visible life than the surface of Mars might have. At least on Mars, scientists hold out hope for something interesting hiding in the soil. In central Antarctica, the soil, where it exists at all, has been tested and found to be almost completely lifeless. The cold is too extreme, the dryness too absolute, the UV radiation too intense when the sun is up. Evolution has produced some remarkably tough organisms over the past few billion years. But even evolution looked at the Antarctic plateau and said, you know what? I'm going to sit this one out. The coasts are a different story, and we should acknowledge that before moving on. Antarctic shores are famously teeming with life: penguins, seals, seabirds, and the whales and fish that feed in the nutrient-rich waters. But here's the thing. None of these animals actually live in Antarctica. They live on Antarctica, temporarily, when conditions permit. Penguins breed on the coast and then spend most of their lives in the ocean. Seals haul out onto the ice to rest and reproduce, but the sea is their real home. There are no land mammals, no terrestrial birds that stay year-round, no permanent residents in the way that the Arctic has polar bears and foxes and caribou. Antarctica's wildlife is essentially a seasonal tourist population, visiting when the weather allows and leaving before things get serious. The largest permanent land animal in Antarctica is a wingless midge called Belgica antarctica, and it measures about 6 millimeters long. That is roughly a quarter of an inch. This tiny fly, which cannot even fly, is the undisputed heavyweight champion of Antarctic terrestrial fauna. It survives by living in coastal areas where temperatures occasionally rise above freezing in summer, spending most of its life frozen solid and then thawing out to feed and reproduce during brief windows of slightly less terrible conditions. If Belgica antarctica were a person, it would be that one coworker who somehow thrives in the office everyone else hates. Respect, honestly. So on the surface, Antarctica is biologically barren to a degree that is hard to comprehend. But surfaces can be deceiving, and this is where the story gets interesting. Because while the top of Antarctica wants nothing to do with life, the bottom, the hidden world beneath the ice, might be a completely different story. We already talked about the subglacial lakes, those liquid water reservoirs sealed away for millions of years. The question of whether life exists in those lakes is still unanswered. But the broader question, whether life can exist anywhere beneath the Antarctic ice, has actually been settled. It can. It does. We have found it. In 2014, scientists drilling through the West Antarctic ice sheet discovered microbial life in the sediments beneath a glacier. Not in a lake, mind you, but in the mud and rock at the base of the ice, where crushing pressure and geothermal warmth create a thin layer of liquid water. These microbes were not particularly glamorous. Bacteria and archaea, the usual suspects when you are looking for life in extreme environments. But their existence was profound. Life had found a way to persist in conditions that would seem utterly incompatible with survival. No sunlight ever reaches these depths. The pressure is immense. The temperatures hover just barely above freezing. And yet, there they were, quietly metabolizing, reproducing, doing their microbial thing. The discovery raised an obvious question. How do they survive? What do they eat? In most ecosystems, the food chain starts with photosynthesis, plants or algae capturing sunlight and turning it into chemical energy that everything else consumes. But there is no sunlight beneath the Antarctic ice sheet. None. Zero. The darkness is absolute, and has been for millions of years. Whatever is living down there has to get its energy from somewhere else. The answer appears to be chemosynthesis, the ability to extract energy from chemical reactions rather than sunlight. Deep-sea hydrothermal vents operate on similar principles, with bacteria feeding on hydrogen sulfide and other chemicals spewing from the Earth's crust. Beneath Antarctica, the microbes seem to be feeding on minerals in the bedrock, extracting energy from the slow grinding of ice against stone and the geochemical processes that occur in those dark, pressurized depths. It is not a lavish lifestyle by any means. These organisms are probably growing incredibly slowly, maybe dividing once every few decades or centuries rather than the minutes or hours that surface bacteria enjoy. But they are alive, and they are apparently happy enough with the arrangement to have been doing it for a very long time. Now, here is where Antarctica stops being just a strange place on Earth and starts becoming a preview of what we might find elsewhere in the solar system. Because those conditions I just described, no sunlight, liquid water maintained by pressure and internal heat, possible chemosynthetic life, sound an awful lot like what scientists expect to find on certain moons orbiting Jupiter and Saturn. Europa, one of Jupiter's moons, has a surface covered in ice. Beneath that ice, evidence suggests there is a global ocean of liquid water, kept warm by tidal forces from Jupiter's immense gravity. Enceladus, a moon of Saturn, is even more dramatic. It has geysers actively shooting water vapor into space, strongly implying a subsurface ocean that is not only liquid, but potentially heated by hydrothermal activity. Both of these worlds are considered prime candidates in the search for extraterrestrial life, and both of them have conditions remarkably similar to what we find beneath Antarctica. This is not a coincidence, and it is why Antarctic research has become so important to astrobiology. Every technique we develop to study life beneath Antarctic ice, every protocol we create to avoid contaminating pristine environments, every discovery we make about how organisms survive without sunlight, all of it is practice for the missions that will eventually drill through the ice of Europa or sample the plumes of Enceladus. Antarctica is our test kitchen for extraterrestrial exploration, a place where we can make mistakes and learn lessons before the stakes involve billion-dollar spacecraft and irreplaceable opportunities. And the lessons have been humbling. We have learned that detecting life in these environments is incredibly difficult. The organisms are sparse, the signals are weak, and distinguishing genuine finds from contamination is a constant battle. We have learned that drilling through miles of ice without introducing surface microbes is nearly impossible with current technology. And if we cannot do it on Earth, where we can iterate and improve, we are definitely not ready to do it on a moon orbiting Jupiter. We have learned that even when we find life, understanding what it is and how it works requires sophisticated analysis that pushes the limits of our scientific instruments. But we have also learned that life is tenacious in ways that should give us hope. If microbes can survive beneath Antarctic ice, feeding on rocks in eternal darkness, then the universe might be far more inhabited than we once assumed. Every extreme environment on Earth that we expected to be lifeless has turned out, upon closer inspection, to host something. Hot springs, acid pools, deep underground aquifers, Antarctic ice sheets. Wherever there is liquid water and a source of energy, life seems to find a way. The late scientist Carl Sagan once said that the universe is not required to be in perfect harmony with human ambition, but it might be more hospitable to life in general than our ambitions gave it credit for. There is another frontier of Antarctic biology that we have not touched on yet, and it is wonderfully weird. Volcanic ice caves. Remember how we mentioned that Antarctica has volcanoes beneath its ice? Well, some of those volcanoes are active enough to melt channels and chambers in the ice above them. Mount Erebus, the continent's most active volcano, has created a network of caves where volcanic heat meets glacial ice, producing environments that exist nowhere else on Earth. Inside these caves, the temperature is actually warm enough to support life, even while the outside world is frozen solid. Scientists exploring Erebus ice caves have found algae, mosses, and bacterial communities living in conditions that blend volcanic and polar extremes. It is like finding a tropical greenhouse inside a freezer, unexpected, a little surreal, and scientifically fascinating. These caves are another reminder that Antarctica is not uniformly hostile, but rather a patchwork of microenvironments, some of which have found ways to nurture life despite the broader continental death wish. The existence of these volcanic refugia also complicates the question of what Antarctica was like in the past. We know the continent was once warm and forested, tens of millions of years ago. As it froze over, did any of that ancient life find shelter in volcanic hotspots? Could there be lineages of organisms that have survived in Antarctic caves since before the Ice Age began, evolving in isolation while the rest of the continent went into deep freeze? The idea sounds like science fiction, but then again, so did subglacial lakes until we actually found them. The biological paradox of Antarctica comes down to this. A continent that appears dead is actually riddled with potential life, hidden in places we cannot easily reach, and surviving in ways we are only beginning to understand. The surface says no living thing shall pass, but beneath that surface, in the cracks and caves and water pockets, life whispers, actually we are doing fine down here, thanks for asking. This paradox matters beyond just Antarctic science. It matters for how we think about habitability in general. For most of human history, we assumed that life required conditions similar to what we experience on Earth's surface. Moderate temperatures, liquid water, sunlight, oxygen, all the usual suspects. Antarctica, along with other extreme environments, has taught us that life's requirements are far more flexible. Give an organism liquid water and an energy source, and it might surprise you with what it can accomplish. When we finally send probes to drill through Europa's ice shell, or fly through the plumes of Enceladus, we will be looking for exactly the kinds of organisms we are finding beneath Antarctica. Not complex life, probably not anything we would recognize as charismatic, but microbial communities clinging to existence in environments that would kill us instantly. And if we find them, when we find them, some scientists would argue, it will be the discovery that redefines humanity's place in the universe. We will know that Earth is not unique, that life is not a cosmic accident, that the same tenacity we see beneath Antarctic ice extends across the solar system and probably beyond. Antarctica is the rehearsal. The moons of Jupiter and Saturn are the main performance. And whatever we find in those frozen depths, on Earth or elsewhere, will force us to expand our definition of what it means for a world to be alive. Everything we have discussed so far, the impossible cold, the murderous winds, the hidden lakes and buried mountains, might sound abstract if you are sitting comfortably at home watching this on your phone. But for a brief window in the early 20th century, a small group of extraordinary and possibly slightly unhinged individuals decided to test these conditions personally. What followed was one of the greatest adventure stories ever told, complete with heroes, villains, depending on who is telling the story, triumph, tragedy, and enough frozen drama to fuel 100 movies. This is the tale of the race to the South Pole, and it has everything except a happy ending for everyone involved. The year was 1910, and the South Pole was the last great geographical prize on Earth. The North Pole had been claimed just a year earlier, though the claims were disputed, and the whole affair was kind of a mess. But the South Pole was different. The South Pole was definitive. It sat in the middle of a continent, surrounded by hundreds of miles of ice, unreachable by any method except walking, or skiing, or dog sledding, or some combination of all three. Whoever got there first would cement their name in history forever. The only question was, who would be crazy enough to try? Enter our two main characters, Roald Amundsen of Norway and Robert Falcon Scott of Britain. On paper, these two could not have been more different. Amundsen was a polar specialist, a man who had spent his entire adult life preparing for exactly this kind of challenge. He had sailed the Northwest Passage, studied indigenous Arctic survival techniques, and approached exploration with the cold efficiency of an engineer solving a logistics problem. Scott, meanwhile, was a Royal Navy officer who had led one previous Antarctic expedition, but whose expertise lay more in naval tradition and British determination than in polar survival. Where Amundsen saw a technical challenge to be optimized, Scott saw a test of national character to be endured with stiff upper lips and proper form. Their approaches to reaching the pole reflected these differences in ways that would prove fateful. Amundsen bet everything on dogs. Sled dogs specifically. Teams of hardy, well-trained animals that could pull heavy loads across the ice and, crucially, serve as emergency food if things went wrong. This might sound brutal, and it was, but Amundsen was nothing if not practical. He calculated exactly how many dogs he would need, planned to kill and eat some along the way to feed both men and surviving dogs, and designed his entire expedition around maximizing speed and efficiency. It was ruthless, it was unsentimental, and it worked brilliantly. Scott, on the other hand, went with a mixed approach that included ponies, motor sledges, and dogs, but ultimately relied on the most British solution imaginable: man-hauling. Yes, that means exactly what it sounds like. Scott's plan was for his men to pull their own sledges across hundreds of miles of Antarctic ice, dragging everything they needed through the snow using their own muscle power. The motor sledges broke down almost immediately. Turns out, early 20th century engines did not love operating at 40 below zero. Who could have guessed? The ponies, which were not adapted to polar conditions, struggled and died. And so the British expedition found themselves doing it the hard way, because apparently suffering was considered character building. This is not to say Scott was incompetent. He was not. He was a capable leader, working within a tradition that valued certain qualities: courage, endurance, sacrifice, over pure efficiency. The problem was that Antarctica did not care about tradition. The continent did not give extra points for doing things the hard way. It just killed you slightly faster if your methods were suboptimal. Amundsen left his base camp at the Bay of Whales on October 19, 1911, with 4 companions and 52 dogs. Scott left from Cape Evans on November 1st, with a larger party that would gradually thin out as support teams turned back. The routes were different. Amundsen was closer to the pole but had to cross an unknown glacier, while Scott followed a previously explored path up the Beardmore Glacier. But both expeditions were heading for the same point, a spot at 90 degrees south where all the lines of longitude converge, and both leaders knew they were in a race, even if neither wanted to admit it publicly. Amundsen's journey was, by Antarctic standards, almost boring in its efficiency. His dogs performed exactly as expected. His supplies were calculated correctly. His team moved fast, averaging 15 to 20 miles per day, skiing alongside the dog sledges and making steady progress across the polar plateau. There were challenges, of course. Crevasses to navigate, weather delays to endure, the constant grinding cold that sapped energy and froze extremities. But nothing went catastrophically wrong. Nothing unexpected happened. Amundsen had planned for everything, and everything went according to plan. On December 14, 1911, Amundsen and his 4 companions reached the South Pole. They planted the Norwegian flag, took photographs, left a letter for Scott, because even in 1911 people understood the importance of receipts, and then turned around and headed home. The return journey was equally smooth. By January 25, 1912, they were back at base camp, all 5 men alive and healthy, with most of their dogs still pulling strong. Total time from base to pole and back, 99 days. Amundsen called it a regular-style trip, which is either extraordinary modesty or world-class understatement. Scott's journey was a different story entirely. Everything that could go wrong did go wrong, sometimes in ways that seemed almost personal. The weather was worse than expected. The snow conditions were terrible for hauling, sometimes too soft, sometimes too hard, never quite right. The ponies died earlier than planned. The motor sledges, as mentioned, were useless. And the man-hauling, while heroic in its own way, was destroying the team physically. They were burning far more calories than they were consuming, getting weaker every day, covering less ground than they needed to. Scott's polar party, himself and 4 others, reached the South Pole on January 17, 1912, 34 days after Amundsen. They found the Norwegian flag already flying, the tent with Amundsen's letter inside, and the crushing realization that all their suffering had been for second place. Scott's diary entry from that day is famous. Great God, this is an awful place, and terrible enough for us to have labored to it without the reward of priority. Not exactly gracious in defeat, but you can understand the sentiment. They had walked 800 miles through hell, and someone else had gotten there first. But reaching the pole was only half the journey. They still had to get back. And this is where Scott's expedition transformed from disappointment into tragedy. The return march began badly and got worse. One team member, Edgar Evans, had suffered a head injury during the outward journey and was deteriorating rapidly. He collapsed and died in mid-February, becoming the first casualty. Lawrence Oates, another team member, was suffering from severe frostbite. His feet were essentially destroyed, slowing the entire party. In one of the most famous acts of self-sacrifice in exploration history, Oates reportedly walked out of the tent one night, saying, "I am just going outside and may be some time." He never came back. He was deliberately sacrificing himself to give his companions a better chance, though by that point, their chances were already slim. Scott, Edward Wilson, and Henry Bowers continued struggling north, but they were caught by a blizzard just 11 miles from a supply depot that could have saved them. The storm pinned them down for days, then weeks. They ran out of food and fuel. They could not move. Scott's last diary entry, written around March 29, 1912, includes the line, "For God's sake, look after our people." A search party found their tent 8 months later, the 3 men frozen in their sleeping bags, Scott's arm draped over Wilson, the diaries and letters that would make them legends scattered around them. The contrast between the 2 expeditions could not be starker. Amundsen planned meticulously, used the right tools for the job, and achieved his goal with almost anticlimactic efficiency. Scott planned bravely, relied on methods that prioritized spirit over practicality, and paid for it with his life and the lives of his men. History has debated their relative merits ever since. Was Amundsen a cold-hearted pragmatist who cared only about winning? Was Scott a romantic fool who got his men killed through poor planning? The truth, as usual, is more complicated than either caricature. What the race to the pole really demonstrated was something we have been discussing throughout this entire video. Antarctica does not negotiate. The continent does not care about your national pride, your scientific ambitions, or your personal courage. It has rules, physical, immutable rules about cold and distance and human endurance, and if you break those rules, you die. Amundsen understood this and built his expedition around working within Antarctica's constraints. Scott understood it too, intellectually, but his approach asked more of the continent than the continent was willing to give. The heroic age of Antarctic exploration, as historians call this period, produced many such stories. Ernest Shackleton's Endurance expedition, which happened a few years later, is another legendary tale of survival against impossible odds, though in that case, everyone actually survived, which is almost miraculous. But Scott and Amundsen's race remains the defining narrative of this era, a morality play about preparation versus pluck, efficiency versus endurance, the cold calculations of survival versus the warm glow of human spirit. And what strikes me most, looking back at these stories from our comfortable modern perspective, is how close to the edge everyone was operating. These were not stupid people. They were among the best prepared, most experienced, most capable explorers of their generation. They had the best equipment available, the most detailed maps, the support of entire nations, and Antarctica still nearly killed all of them. Scott's party did not fail because they made obvious mistakes. They failed because they made small miscalculations that, compounded over hundreds of miles and months of travel, added up to disaster. The margins were that thin. The continent was that unforgiving. Today, reaching the South Pole is almost routine. There are flights, heated research stations, GPS navigation, and emergency rescue capabilities. Tourists pay tens of thousands of dollars to ski to the pole with guided expeditions, following in Scott and Amundsen's footsteps with Gore-Tex jackets and satellite phones. It is still dangerous, still challenging, but it is no longer the death sentence it was a century ago. Yet even with all our technology, we have not truly conquered Antarctica. We have established a foothold, maintained a presence, conducted invaluable research. But we have not made the continent safe or hospitable or anything resembling home. The polar parties of the heroic age taught us exactly what kind of place this is. A place that tolerates human presence only under very specific conditions and punishes deviation with swift and absolute finality. Every researcher who winters at a polar station, every tourist who visits the peninsula, every scientist who drills into the ice sheet is walking in the footsteps of people who did not come back. The continent remembers. After all the drama of exploration, all the frozen bodies and national flags planted in ice, you might expect Antarctica to have become yet another stage for human conflict. After all, that is what usually happens when countries discover valuable territory. They fight over it. They draw lines on maps, send soldiers, build fortifications, and generally make a mess of things. This pattern has repeated itself across every continent humans have ever touched, from the scramble for Africa, to the colonization of the Americas, to the endless boundary disputes that still flare up today. But Antarctica took a different path, and honestly, it is one of the few genuinely heartwarming stories in the history of international relations. Which is saying something, because international relations is not exactly famous for heartwarming stories. It is more famous for wars, betrayals, and diplomats yelling at each other in expensive conference rooms. Yet somehow, against all odds and against all historical precedent, the nations of the world looked at Antarctica and collectively decided, you know what? Let us not ruin this one. The result was the Antarctic Treaty of 1959, and it remains one of the most remarkable documents in diplomatic history. To understand why it matters, we need to back up a bit and look at what the situation was like before the treaty existed. By the mid-20th century, 7 countries had staked territorial claims to Antarctica. Britain, Norway, France, Australia, New Zealand, Chile, and Argentina all drew wedge-shaped slices on the map, like someone dividing a very cold and very unappetizing pie. These claims overlapped in some places, particularly on the Antarctic Peninsula, where Britain, Chile, and Argentina all insisted the same chunk of ice belonged to them. Tensions were real. During World War II, there were actual military operations in Antarctic waters, and afterward, the Cold War added another layer of paranoia to everything. The Soviet Union and the United States, notably, had not made territorial claims, but also had not recognized anyone else's. They were keeping their options open, which in diplomatic terms usually means, we might want this later, so nobody else can have it. The situation was a mess waiting to explode. You had rival claims, great power competition, and a continent full of resources that nobody could access yet, but everyone assumed would be valuable someday. All the ingredients for a colonial free-for-all were present. The only thing missing was the actual fighting, and that seemed like just a matter of time. Then something unexpected happened. Science got in the way. The International Geophysical Year of 1957 to 58 was supposed to be a massive global scientific collaboration, with research projects spanning the entire planet. Antarctica was a major focus because it was scientifically fascinating and politically neutral. Or at least, scientists preferred to pretend it was neutral so they could actually get work done. Researchers from a dozen countries established bases across the continent, shared data, cooperated on projects, and generally demonstrated that international collaboration was possible even during the tensest years of the Cold War. American and Soviet scientists worked side by side, exchanging information about ice cores and atmospheric measurements, while their governments pointed nuclear missiles at each other back home. This was not supposed to work. Everything about Cold War logic said that American and Soviet scientists should have been sabotaging each other, stealing data, and generally treating Antarctica as another front in the ideological struggle. Instead, they became colleagues, friends even. They realized that the challenges of Antarctic research were too big for any single nation, and that sharing resources and knowledge made everyone's science better. It was a temporary arrangement. The International Geophysical Year was scheduled to end, but nobody wanted to go back to the old system of territorial squabbling. So the diplomats got involved, and for once, they did something genuinely impressive. In 1959, 12 countries, the 7 claimants plus the United States, Soviet Union, Belgium, Japan, and South Africa, signed the Antarctic Treaty. The document was remarkably short, just 14 articles, but its provisions were revolutionary. First, and most importantly, the treaty froze all territorial claims. Not resolved them, not adjudicated them, just froze them in place. The countries that had claimed territory could keep claiming it, but those claims would not be recognized or enforced. Countries that had not claimed territory agreed not to make new claims, and everyone agreed that nothing anyone did in Antarctica would strengthen or weaken any existing claim. This was diplomatic genius because it sidestepped the impossible question of who actually owned the continent. Nobody had to give up their position. They just had to agree not to act on it. Second, the treaty demilitarized the continent entirely. No military bases, no weapons testing, no military maneuvers, no fortifications. Antarctica would be reserved exclusively for peaceful purposes. The only military personnel allowed were those supporting scientific research, and they had to leave their weapons at home. In an era when the superpowers were turning every corner of the globe into a potential battlefield, this was extraordinary. An entire continent removed from the game board. Third, the treaty established freedom of scientific investigation and required the sharing of research results. Any country could conduct research anywhere on the continent, regardless of who claimed that territory. Data had to be made available to all signatories. Scientific cooperation was not just encouraged, but mandated. This turned Antarctica into a kind of global laboratory, where competition was replaced by collaboration, and national prestige came from discoveries rather than conquests. Fourth, and this is the part that gives the treaty teeth, it established a system of inspections. Any signatory country can inspect any other country's facilities at any time, without prior notice. This sounds like a minor administrative detail, but it was actually unprecedented. Countries agreeing to let other countries poke around their bases whenever they want? In 1959, during the Cold War, the level of trust required for this provision was remarkable. And the fact that it worked, that inspections actually happened and countries actually complied, speaks to how seriously everyone took the Antarctic experiment. The treaty entered into force in 1961, and in the decades since, it has been strengthened by additional protocols. The Madrid Protocol of 1991 banned mining and mineral extraction for at least 50 years, designating Antarctica as a natural reserve devoted to peace and science. This was a direct response to growing interest in Antarctic resources. There are significant coal deposits, possible oil reserves, and various mineral resources beneath the ice, and it represented a collective decision to prioritize preservation over exploitation. Not because anyone had become particularly noble, but because everyone recognized that a mining free-for-all in Antarctica would be an environmental and diplomatic catastrophe. Today, the Antarctic Treaty System includes 54 countries, representing about 2/3 of the world's population. There are dozens of permanent research stations operated by various nations, studying everything from climate change to astronomy to the biology of extremophiles. The continent hosts around 5,000 researchers in summer and about 1,000 in winter, all working under the framework established by that 1959 agreement. It is not a perfect system. There are disputes, there is political maneuvering, and some countries definitely push the boundaries of what counts as scientific research, but it is functional. It works. And it has worked for over 60 years without a single armed conflict. Think about that for a moment. 60 years of international cooperation on a continent that multiple countries claim to own. No wars, no invasions, no proxy conflicts, no border disputes resolved by force. In a world where nations routinely fight over tiny islands and patches of desert, Antarctica stands as proof that humans can choose cooperation when the stakes are high enough and the alternative is ugly enough. But the system faces threats, and pretending otherwise would be naive. The most obvious threat is resources. As climate change makes Antarctica more accessible, and as global demand for minerals, fresh water, and fossil fuels increases, the temptation to exploit the continent will grow. The Madrid Protocol's mining ban expires in 2048, and there is no guarantee it will be renewed. Already, some countries are positioning themselves for potential future extraction, building infrastructure, establishing presence, conducting suspiciously detailed geological surveys. The claim freezing provision of the original treaty suddenly looks less stable when there might actually be something worth claiming. Climate change itself is a threat to the treaty system, though in indirect ways. As ice shelves collapse and glaciers retreat, new areas become accessible. Shipping routes that were impossible a few decades ago are now feasible, at least seasonally. Tourism is increasing dramatically. Tens of thousands of visitors now arrive each year, raising questions about environmental impact and regulation. The continent that was once too hostile to fight over may become attractive enough to compete for, and competition has a way of escalating. There is also the question of new players. When the Antarctic Treaty was signed, it was dominated by Western powers and the Soviet Union. Today, China operates multiple research stations and has invested heavily in Antarctic infrastructure. Other emerging powers are expanding their presence as well. These countries were not part of the original negotiations and do not necessarily share the assumptions that shaped the treaty. They are playing by the rules for now, but rules have a way of changing when the balance of power shifts. Finally, and perhaps most fundamentally, the treaty depends on a kind of collective restraint that is rare in international politics. It depends on countries choosing long-term cooperation over short-term advantage, on scientific values trumping economic interests, on mutual trust in an arena where trust is usually in short supply. This restraint has held for 6 decades, but 6 decades is not that long in historical terms. The concert of Europe lasted longer before collapsing into World War I. The post-World War II liberal order seemed permanent until it started cracking. Systems that seem stable can become unstable surprisingly quickly when circumstances change. None of this is meant to suggest that the Antarctic Treaty will fail. It might not. It might adapt and evolve and continue functioning for another century or more. The point is that its success is not guaranteed, and preserving it will require active effort from the international community. Antarctica's unique status as a zone of peace and science is not a natural law. It is a human choice, renewed every day by the decisions of governments, researchers, and ordinary people who believe that some places are too valuable to ruin. And here's the thing that makes Antarctica's story genuinely inspiring. It proves that we can make that choice. Humans are not inevitably doomed to conflict and exploitation. When we recognize that something is precious enough, we can set aside our usual competitive instincts and work together. We can create spaces that belong to everyone and no one, that serve the common good rather than national interests. We have done it at least once, on the coldest and most remote continent on Earth. Maybe we can do it again, in other places, for other reasons. That is the legacy of the Antarctic Treaty. Not just a legal framework for managing a frozen continent, but a proof of concept for a better way of sharing the planet. The question is whether we will learn from it, or eventually forget the lessons it taught. By now, you might be thinking, okay, sure, Antarctica was impossible to explore 100 years ago. Scott and Amundsen were working with wooden ships, cloth tents, and dogs. But we live in the future now. We have satellites that can read license plates from orbit. We have robots exploring Mars. We have artificial intelligence, advanced materials, drones, GPS, and smartphones more powerful than the computers that landed humans on the moon. Surely, with all this technological wizardry, Antarctica should be an open book by now. Right? Wrong. Spectacularly, humiliatingly wrong. And the reasons why reveal just how far outside normal operating parameters this continent really sits. Let us start with satellites, because satellites are supposed to be our all-seeing eyes in the sky. Modern Earth observation satellites can detect objects a few centimeters across, track temperature changes, measure ice thickness, and monitor everything from deforestation to traffic jams. They have revolutionized how we understand our planet. But Antarctica has a way of making even our best technology look foolish. The first problem is geometry. Antarctica sits at the bottom of the world, which means satellites in typical orbits, the kind that give us Google Maps imagery of your backyard, do not pass over it frequently or at useful angles. Polar orbiting satellites can image the continent, but they have their own limitations. Coverage is patchy, revisit times are long, and the viewing angles often make detailed analysis difficult. It is not like imaging Kansas, where you can get a nice perpendicular shot with consistent lighting. Antarctic imagery is often taken at oblique angles, with wildly varying illumination conditions, making comparisons over time surprisingly tricky. Then there is the surface itself. Antarctica is white, extremely white, blindingly, overwhelmingly, monotonously white. Optical satellites essentially see a blank sheet with almost no distinguishing features across thousands of square miles. There are no roads, no buildings, no vegetation patterns, no rivers. None of the visual cues that make satellite imagery useful elsewhere. Trying to navigate or map interior Antarctica using optical satellites is like trying to read a book printed in white ink on white paper. The information might technically be there, but good luck extracting it. Radar satellites help somewhat. They can penetrate clouds, work in darkness, and detect surface features that optical sensors miss. They can even peer beneath the ice to some extent, revealing the bedrock topography we discussed earlier. But to some extent is doing a lot of work in that sentence. Radar can see maybe the top few dozen meters of ice clearly, with resolution degrading rapidly as you go deeper. The ice sheet is up to 3 miles thick. Radar gives us a fuzzy outline of what is down there, not a detailed map. It is like trying to understand human anatomy by looking at an X-ray taken from a mile away through a snowstorm. The fundamental problem is that satellites, no matter how sophisticated, can only observe the surface and the shallowest subsurface. Everything we have discussed, the buried mountains, the subglacial lakes, the potential life forms, the ice cores containing ancient atmosphere, is beyond their reach. To actually study Antarctica in any meaningful depth, you have to go there physically and dig. And digging, it turns out, is where modern technology really starts to cry. Ice core drilling sounds straightforward in principle. You lower a drill, it cuts a cylinder of ice. You pull it up, repeat until you reach the depth you want. In practice, drilling through Antarctic ice is one of the most technically demanding operations humans have ever attempted, and the challenges multiply as you go deeper. First, there is the cold. Drill equipment has to function at temperatures that would destroy most machinery. Metal becomes brittle, lubricants solidify, electrical systems behave erratically. The drill itself generates heat through friction, which can melt the surrounding ice and cause the borehole to refreeze around your equipment, trapping it permanently. Yes, this has happened. Yes, it is exactly as expensive and frustrating as it sounds. Imagine spending 3 years drilling toward a subglacial lake, getting within meters of your target, and then watching your multi-million-dollar drill become a permanent feature of the ice sheet. That is not a hypothetical. That is Antarctic drilling in a nutshell. The solutions to these problems require engineering that borders on alchemy. Some drilling systems use hot water instead of mechanical drills, essentially melting their way down. This avoids the freezing around your drill problem, but creates new challenges. You need massive amounts of fuel to heat the water, sophisticated plumbing to deliver it at depth, and ways to keep the borehole open as you descend. Other systems use antifreeze fluids in the borehole to prevent refreezing, but then you have to worry about contaminating your samples with the very chemicals keeping your hole open. It is a constant juggling act between mechanical requirements and scientific purity. And let us talk about what drilling actually means in terms of time and money. The Vostok Ice Core project, which reached about 3.5 kilometers deep, took over 2 decades from initial drilling to final depth. 2 decades. The Epica project at Dome C, which produced the 800,000-year climate record, involved years of drilling operations and cost tens of millions of dollars. A proposed project to drill even deeper, targeting ice that might be over 1 million years old, has been in planning stages for years and would require international collaboration, specialized equipment that does not fully exist yet, and budgets that make research administrators weep. Each meter of depth represents extraordinary effort, and the ice sheet has 3,000 meters to give before you even reach rock. Now you might think, robots. Why not send autonomous machines to do the drilling and exploring? That is what we do on Mars, after all. The Perseverance rover is happily trundling around the red planet right now, drilling samples, taking selfies, and generally doing science without humans freezing their fingers off. Why not build Antarctic robots? The answer is that we have tried, and Antarctica keeps breaking them. The temperatures in Antarctica's interior are actually colder than what we design Mars rovers to handle. That sounds absurd. Mars is farther from the Sun, obviously. But Mars rovers operate in temperatures that bottom out around -120 Celsius, and they are specifically engineered for that environment with every component tested and retested in thermal chambers. Meanwhile, autonomous systems designed for Earth's surface were not built with Antarctic conditions in mind. Commercial drones, for instance, have batteries that lose most of their capacity in extreme cold. Their motors become sluggish. Their sensors fog up or freeze. Their communication systems struggle with the unique electromagnetic environment near the poles. You can modify these systems for cold weather, but modification only gets you so far when the baseline assumptions of the design are wrong. Even purpose-built Antarctic robots face enormous challenges. Power is a constant issue. Solar panels are useless during the months-long polar night, and batteries drain rapidly in the cold. The continent has no infrastructure, which means any robot has to either carry all its power with it or have a human support team nearby with generators and fuel. But wait, fuel is also a problem. Diesel fuel starts to gel and become unusable below about -40 Celsius. Aviation fuel and specialized polar blends help, but they are expensive and have to be shipped in from the outside world. In Antarctica, even the energy to run your technology becomes a logistical nightmare. Then there is GPS, which we all take for granted these days. Surely GPS works everywhere. It is satellites, it is space-based, it should not care about ground conditions. And technically, GPS does work in Antarctica. The signals reach the surface just fine. The problem is what happens when you try to use those signals for precision navigation near the poles. GPS satellites orbit the Earth around the equator, which means their coverage gets progressively thinner as you approach the poles. There are fewer satellites visible at any given time, and they are clustered toward the horizon rather than spread across the sky. This geometry degrades accuracy significantly. In the continental United States, GPS might give you precision within a meter or two. In interior Antarctica, you might be looking at errors of 10 meters or more, and that is on a good day with favorable satellite configurations. On a bad day, when satellites are bunched together and atmospheric conditions are funky, your position fix might be off by dozens of meters. This might not sound like a big deal until you remember that Antarctica has crevasses, deep cracks in the ice, sometimes hidden by thin snow bridges, that can swallow vehicles, equipment, and people without warning. Navigation errors of a few meters can mean the difference between a safe route and a fatal one. Early Antarctic expeditions used flags and careful dead reckoning to mark safe paths across the ice. Modern expeditions use GPS, but they still plant flags, because trusting your life to a satellite system with known polar limitations is not something sensible people do. Communication is another weak point. Antarctica has no cell towers, obviously, no internet infrastructure, no landlines. The only way to communicate with the outside world is via satellite, and satellite communication in polar regions is, you guessed it, problematic. Geostationary satellites, which provide most global communication services, sit over the equator and are geometrically invisible from high polar latitudes. You literally cannot see them from central Antarctica. The curvature of the Earth blocks the line of sight. Polar research stations rely on different satellite constellations with lower orbits, but these provide intermittent coverage rather than constant connectivity. There are windows when communication is possible, and windows when you are completely cut off. Scheduling calls, sending data, and coordinating operations all have to work around these blackout periods. The isolation this creates is profound and has real consequences. When something goes wrong at an Antarctic research station during winter, help is not coming. Aircraft cannot fly in the darkness and extreme cold of polar winter. The conditions are beyond even specialized aircraft capabilities. Ships cannot break through the winter ice. For roughly 8 months of the year, personnel at interior stations are completely on their own. Medical emergencies become potential death sentences. Equipment failures that would be minor inconveniences elsewhere become existential crises. This is not technology failing. It is technology meeting the absolute limits of what is possible. And here is perhaps the most humbling part. Even with all our advances, we have barely explored the continent. The ice sheet covering Antarctica is roughly 14 million square kilometers. The area that has been directly studied, actually visited and examined by humans or instruments on the ground, is a tiny fraction of that. Most of what we know about the interior comes from remote sensing. Satellites, aircraft overflights, seismic surveys. We have scattered research stations, a few well-studied drill sites, and then thousands of square miles of essentially terra incognita. Places no human has ever stood. Features no instrument has ever directly measured. Mysteries that our technology can detect, but cannot resolve. The kicker is that we have been at this for over a century. Since Scott and Amundsen raced to the pole, we have developed airplanes, helicopters, nuclear power, digital computers, the internet, nanotechnology, genetic engineering, and artificial intelligence. We have landed robots on Mars and comets. We have photographed black holes. We have sequenced the human genome. And Antarctica remains stubbornly, almost mockingly, beyond our grasp. The continent has not changed in 100 years. Same ice, same cold, same winds. But our relationship with it has not changed as much as we might like to think. This is not a story about technology being bad or insufficient. Technology has enabled everything we have learned about Antarctica, from climate records to biodiversity to geological structure. But it is a story about limits, about the recognition that some environments exist at the edge of what our tools can handle, and that advancing those tools is neither automatic nor guaranteed. Antarctica pushes back. It demands innovations we have not made yet, materials we have not invented, approaches we have not imagined. And until we develop them, if we develop them, the continent will keep most of its secrets locked away under 3 miles of ice, daring us to try harder. We have covered a lot of ground in this journey, or rather, a lot of ice. We have talked about geography and climate, about buried mountains and hidden lakes, about explorers who triumphed and explorers who died, about treaties and technology, and the stubborn refusal of a continent to submit to human will. But now I want to step back and ask a different kind of question. Not how Antarctica works, but what Antarctica means. Because here's the thing. In the 21st century, we are not used to places we cannot conquer. We have climbed every mountain, crossed every ocean, mapped every island, and cataloged every species we could find. We have put footprints on the moon and tire tracks on Mars. We have built cities in deserts, tunneled through mountains, and drained swamps to create farmland. The entire history of human civilization can be read as a story of expanding control, taking the wild and making it tame, taking the unknown and making it known, taking the impossible and making it merely difficult. Antarctica does not fit this story. It refuses to participate. And that refusal, I would argue, is one of the most valuable things about it. Think about how we typically relate to nature. We see a forest and think about timber. We see a river and think about hydroelectric power. We see a mineral deposit and think about extraction. This is not necessarily evil or wrong. It is how humans have survived and prospered for thousands of years. We are a species that transforms environments to suit our needs, and that ability is part of what makes us remarkable. But it has also made us forget something important. We are not actually in charge. Antarctica remembers. Antarctica insists, every single day, that there are forces in this world larger than human ambition, older than human civilization, and utterly indifferent to human plans. You can bring your best technology, your most brilliant scientists, your most determined explorers, and Antarctica will look at all of it and shrug. Not with hostility necessarily. Hostility implies awareness, and the continent is not aware of us. It simply continues being what it is: cold, vast, ancient, and completely unconcerned with whether we approve. This is humbling in a way that modern life rarely provides. We live in bubbles of control: climate-controlled homes, predictable commutes, curated information feeds, same-day delivery of almost anything we want. The natural world, for most people in developed countries, is something that happens in parks and nature documentaries, safely contained and fundamentally optional. You can go your entire life without ever confronting an environment that genuinely does not care whether you live or die. Antarctica offers that confrontation, not as punishment, not as a test of character in some cosmic sense, but simply as fact. Here is a place where the rules are different. Here is a place where your technology fails, your plans collapse, and your assumptions about human capability get stripped away layer by layer like frostbitten skin. If you survive, and people do survive, obviously, every day at research stations across the continent, you come back changed. You come back knowing something about limits that cannot be learned from books or lectures. I find this genuinely inspiring, which might seem strange given that we have spent most of this video talking about death and failure and frozen corpses. But inspiration does not have to mean comfort. Sometimes, inspiration means being reminded that the universe is bigger than you, that your problems are smaller than they feel, that the grand human project of mastery is still, in some fundamental way, incomplete. Antarctica is proof that there are still frontiers. Not frontiers in the old colonial sense of places to exploit and settle, but frontiers in a deeper sense, edges of the known, boundaries of the possible. Places where our maps have to admit they do not know what comes next. There is also something to be said for restraint, and Antarctica teaches that lesson too. The Antarctic Treaty, which we discussed earlier, is essentially a document of collective restraint. It says, "Here is a continent full of resources we could exploit, territory we could claim, advantages we could seize, and we are choosing not to. Not because we are forced, but because we recognize that some things are more valuable, unexploited, than exploited." This is not a lesson humans learn easily. Our instincts run the other direction, toward acquisition and expansion and the transformation of potential into product. But Antarctica suggests another possibility, that leaving something alone can be an act of wisdom rather than weakness, that choosing not to take is sometimes braver than taking, that the greatest respect we can show a place is to let it remain itself. The philosophers have a term for this, negative capability. It originally referred to the ability to remain comfortable with uncertainty and mystery, to resist the urge to resolve every question and explain every phenomenon. Antarctica is a continent-sized exercise in negative capability. It holds mysteries we may never solve, secrets we may never uncover, stories we may never tell. And perhaps that is okay. Perhaps the mystery itself has value that understanding would diminish. Consider the subglacial lakes we discussed, those ancient bodies of water sealed away for millions of years. Scientists desperately want to know what is in them. The possibility of unique life forms, of ecosystems that evolved in complete isolation, is scientifically irresistible. But every attempt to study those lakes risks contaminating them, destroying the very thing we want to understand. This is not a technical problem with a technical solution. This is a philosophical dilemma about the relationship between knowledge and preservation. Do we have the right to open every door? Is understanding always worth the price of obtaining it? These are not questions with easy answers, and Antarctica forces us to ask them in concrete rather than abstract terms. The lakes are real, the contamination risks are real, the choices are real. And whatever we decide, to drill or not to drill, to sample or not to sample, says something about who we are and what we value. I think there is wisdom in approaching Antarctica with humility rather than conquest. Not because conquest is impossible, though it largely is, but because the attitude of conquest misses the point. Antarctica does not need to be conquered. It does not need to be tamed or developed or turned into something useful. Its value lies precisely in being what it already is, the last great wilderness, the final frontier, the one place on Earth where nature remains in charge. This does not mean we should stop studying Antarctica. Scientific research there has produced invaluable insights about climate, geology, biology, and the history of our planet. It will continue to produce such insights for as long as we have the resources and will to maintain our presence there. But there is a difference between studying a place and subduing it, between learning from a place and exploiting it. Antarctica invites the former while punishing the latter, and that distinction matters. In an age of climate change, resource depletion, and environmental crisis, Antarctica also serves as a kind of warning and promise rolled into one. The warning is obvious. This frozen continent holds enough ice to raise global sea levels catastrophically, and that ice is already beginning to move in ways that should concern us. The promise is subtler, but equally important. Here is proof that international cooperation can work, that restraint can be chosen, that humanity is capable of setting limits on itself when the stakes are high enough. Whether we heed the warning or keep the promise remains to be seen. But Antarctica will be there either way, patient and cold and utterly indifferent to our decisions. It has outlasted everything else that has tried to change it. The ancient forests that once grew there, the dinosaurs that once walked there, the glaciers that have advanced and retreated over millions of years. It will probably outlast us too, in one form or another. And maybe that is the deepest lesson of all. Some things are simply bigger than we are, and recognizing that fact is not defeat, but maturity. So here we are, at the end of our journey to the bottom of the world. We have traveled from the abstract, a white shape on a map, to something more real, a place of impossible cold and buried secrets, of heroic tragedy and quiet cooperation, of limits tested and lessons learned. Antarctica is no longer just a destination. It is an idea, a challenge, a mirror reflecting back the best and worst of human ambition. And what does that mirror show us? It shows creatures who reached for the unknown and sometimes paid with their lives. It shows scientists drilling through miles of ice to read the diary of a planet. It shows nations that chose, against all historical precedent, to share rather than fight. It shows technology stretched to its breaking point and beyond. It shows life clinging to existence in places where existence should be impossible. Most of all, it shows a world that remains, stubbornly and beautifully, beyond our complete understanding. Antarctica does not need our conquest. It does not want our conquest. What it needs, what it deserves, is our respect. The respect to study without destroying. The respect to visit without ruining. The respect to acknowledge that some places exist not for human benefit, but simply because they exist, and that is enough. Beneath the ice sleeps the memory of our planet. 800,000 years of atmosphere trapped in bubbles. Mountains older than most life on Earth. Lakes that have not seen sunlight since before our ancestors climbed down from trees. This is not just scientific data. This is heritage. It belongs to everyone and no one, to the past and the future, to the curious child who wonders what is at the bottom of the world, and the researcher who devotes a career to finding out. Perhaps the greatest wisdom we can take from Antarctica is this: not everything needs to be explored. Not everything needs to be exploited. Not everything needs to be explained. Some mysteries are meant to remain mysteries, not because we cannot solve them, but because the solving would cost more than the knowing is worth. Some silences are too precious to break. Antarctica is Earth's last great silence, a continent where the loudest sound is often the wind, where human voices are swallowed by distances so vast they become meaningless, where the only monuments are ice formations sculpted by forces older than memory. It is a place that exists at the edge of experience, always slightly beyond what we can fully grasp, always hinting at depths we have not plumbed. And maybe that is its greatest gift. In a world where everything is photographed, cataloged, reviewed, and rated, Antarctica remains genuinely wild, genuinely unknown, genuinely other. It offers us something increasingly rare: the experience of standing at a boundary and knowing that what lies beyond is not yet ours to claim. The explorers of the heroic age understood this, even as they pushed against it. They wrote in their diaries about the terrible beauty of the place, about landscapes that filled them with awe, even as they suffered through them. They knew they were touching something larger than themselves, something that would outlast their expeditions and their names and their entire civilization. They were right. So the next time you see Antarctica on a map, that white mass at the bottom, often distorted by projection, easily ignored among the colorful countries and blue oceans, remember what it represents. Not emptiness, but fullness too deep to measure. Not absence of life, but life hidden in places we have barely begun to look. Not failure of human achievement, but a reminder that achievement has limits, and those limits are not shameful, but sacred. Sometimes the greatness of a place is measured not by what we take from it, but by what we leave untouched. Sometimes the highest form of exploration is knowing when to stop. And sometimes, on the coldest nights, the frozen continent at the end of the earth dreams its ancient dreams, undisturbed by human footsteps, patient as only something eternal can be patient, waiting not for us to conquer it, but for us to understand why we should not try. Thank you for joining me on this journey. If this video made you see the world a little differently, consider subscribing and sharing it with someone who appreciates the strange and wonderful corners of our planet. Until next time, stay curious, and remember that the most important frontiers are sometimes the ones we choose not to cross.